This is a bit of a tricky word problem, but if we can pick up the hints, it's pretty obvious that this is an optimization question. How do we know that? Well, we've got a particular amount of material that we have to use, so that's basically a restriction. And then we're also asked for, without it really saying the word, it's asking for the maximum amount of soup to be held in the container. So whenever you're asked for a maximum or the fastest or the slowest or the minimum or something like that, like an extreme, we know it is an optimization question where we're going to have to use the first derivative. So we're looking for the maximum amount of soup that can be held, so that is volume. So the first step to any optimization problem is to get a formula for the thing that we're trying to optimize. So we're trying to optimize the volume of a cylindrical can, which is volume is pi r squared times h. That's the area of the base times the height, which is the volume. The next step of optimization problems is use your restriction to get you down to one variable. So we can see in our volume here we have r and h are both variables. Those are the two dimensions. We're going to use our other piece of information, which is 350 is the amount of material we have. So that is the surface area. Well, what's the formula for surface area of a can? 2 pi r squared plus 2 pi r h. They may give this to you on the exam, but this should be pretty well known. So we use this second piece to get down to one variable in our volume formula by using substitution. So I'm either going to replace r or replace h. Since in my surface area formula here I've got an r squared and an r, that's going to be difficult to get on its own, so I'm going to replace h. So I'm going to get h on its own in this surface area formula. So it's 350 minus 2 pi r squared, I'm just bringing that to the other side, and then divide by 2 pi r, and that equals h. So that was just simple algebra getting h on its own. If we simplify this a little bit, this becomes 175 over pi r minus r. And all I did there was divide each term by 2 pi r equals h. Great, now I'm going to use this piece to substitute in for h here, and then my volume formula will be down to just one variable in terms of r, and then we can go ahead and do the calculus piece. So pi r squared, instead of h, it's going to be times 175 over pi r minus r. Multiply through, the pi and the r will cancel, so we get 175r minus pi r cubed. Great, now this is a pretty simple formula in terms of r, so we're ready to differentiate. The reason we want to differentiate, again, it's optimization, it's the next step, and because we're looking for a maximum place, we want to set the first derivative to 0. So let's find the first derivative, so v prime equals 175 minus 3 pi r squared, because the 3 came down and it becomes r squared. Pi is just a constant, so that comes along. Let's set that to 0. 175 minus 3 pi r squared. Add the 3 pi r squared to the other side. So r squared equals 175 over 3 pi. So r equals the square root of 175 over 3 pi, which is about 4.31 centimeters. So what this means is that when the radius is 4.31 centimeters on this can of soup, it's going to maximize the volume, given that we only have this 350 centimeters squared to work with. So it asks for the dimensions. We've got the r. The last thing we need is the h. So we just plug our r back in here, where we have h equals 175 over pi r, and r is 4.31, minus r, which is 4.31, and that'll give us an h of 8.62 centimeters. So these would be the two dimensions, the radius and the height, that you would recommend to the company. Again, classic optimization problem. Let's work on recognizing those. So they give you a particular restriction. In this case, it was a certain amount of material, and they ask for a maximum, or as much soup as possible. That's essentially asking for the maximum. Hopefully these steps were helpful. Get the formula for the thing you want to optimize. Use the other piece of information in the question to help you get that down to one variable. Differentiate, set to 0, and solve. Always send us more questions if you have them at info@arnoldtutoring.com. Thanks.